So in this chapter we will learn about battery management, and we have to know that the battery is a sensitive component in mobile devices, and we have to think about it when we write applications. We must adapt our behavior to the charge of our battery. And if we have low battery, we have to restrict the access to the network. So if all the applications were sensitive to this problem, there will be no problem for battery lifetime. Okay? So the question is how we can build an application which is responsive to the battery status. So first of all, there is a component which is battery manager, which broadcasts information about battery at fixed rate. For instance, the battery is okay, the battery is low, and so on and so on and so on. And so we can just register for this event, or we can ask for this event. To ask for this event, we just have to build a new intent filter and fix this filter for this application, okay? And then the next time an intent will be triggered on the intent bus, we can ask for the battery status. And for instance, we can ask if this battery status is, hey, I have plugged my battery on something with charge, and this is USB, or this is something else, and so on and so on and so on. And so we can adapt the behavior of our application to detect such changes. So now we can ask for the exact level of battery. To do that, we just have to ask for the battery manager.extra level, extra scale, and then we just have to have a small computation about these two elements in order to be able to say you have still 88% of your battery. Okay, now that we are able to grab event for batteries, intent for batteries, we have to modify the Android file.xml as usually in order to declare a receiver that will filter some elements, for instance, action power connected, action power disconnected. So in these two particular cases, I will be notified that my device is charging or not. So I may also want to detect only important variation. For instance, my battery is low. What I have to do when my battery is low, for instance, cut the access to GPS, cut the access to network, and so on and so on and so on. Moreover, when your battery is low, you may want to save data because you do not know how long it will last. And this is maybe the last time where you can save data from your application. So it's just what I said. You have to stop everything that consumes energy when you receive action battery low. So one particular thing that we want to do with battery is to detect when we are plugged in the dock. So what is the interest of doing that? For instance, if you plug your device on the car, you may want to, for instance, cut all phone calls, or cut all Facebook notifications, or something like that, because this may be dangerous. So you can detect that by detecting that action dock event has been detected, and then you can ask, is it a car? So you just have to check the dock state to the extra dock state car or desk or something like that. There are a few applications in Android, but you can define if you detect that I am at work, you just cut the notification, cut the ringtones, and so on. If you detect that I am home, you can enable all of this. If you detect that I'm during the transportation, you can only activate, and so on and so on and so on. So to sum up, managing battery is very important. to have a responsible behavior, and you may think to modify the behavior of your application according to the battery status. If, for instance, you have a map and you receive that battery is low, you may want to notify the user that you will stop using the internet, for instance. And so maybe you have to have a degraded mode, and so on and so on and so on. You can trust the connectivity to optimize the battery, and some receiver can be deactivated at runtime in order to restrict the amount of energy that is consumed by the application.